So basically, this is the schema. That's how it look like. So we have old table with triggers being used to update corresponding rows in the new table of the writes. In the same time, there's copying. This data is being copied in small chunks in the background, and at some point, there's tables being renamed. It starts accepting traffic. The old table is deleted. What is good here is this is a point-in-time change. So the new table starts accepting traffic at the same point of time on every node, every host in the topology. Therefore, you can use it for any DDL because there won't be a problem of having different versions of the schema on different hosts. PTLI schema change is replication aware, and so it monitors the replication lag, and if the lag crosses the defined threshold, the PTLI schema change will stop itself, basically. It will pause itself and wait until the lag goes below the threshold. Of course, this tool introduces additional load because of the triggers that are required to move the data around, and of course because of those additional inserts which are being used to copy the data from old to new table. It has some issues with foreign keys. Mainly, that's especially true for the replication, because if there are large tables referenced using the foreign key, those tables has to be altered using regular alter, and this will create lag. So that's a potential issue with the replication here. PTLI schema change can't work with tables which have no triggers. Which have triggers already, at least in 5.6. Up to 5.6. This is because until up to 5.6, only one trigger of given type can be created on a particular table. This limitation has been removed in 5.7, but to be honest, I haven't seen how it works with PTLI schema change. It should, but this is something which probably needs to be tested. And of course, the last limitation here that we can think of is that it don't work with tables which don't have primary key or unique key. It is because it uses those indexes to locate, the boundaries of the chunks of the data that is being copied using those low priority inserts. And otherwise, except for those limitations, the PTLI schema change is a really reliable tool. So the problem is that it creates some impact, and the schema changes may take a long time. But thanks to its throttling ability, this is really it makes those changes still feasible to execute. You can actually even force a pause on this tool at any given time. So it's one of the most important tools DBA has, and sometimes it's really the only way to execute the change without taking a long downtime. So next we're going to discuss topology changes themselves. But first, back to you, JJ, for another pool.
Yeah, great. Thanks, Krzysztof. So before we get diving into the next topic, we wanted to ask all of you what topology you currently use, as that will be interesting for the next few minutes as well, to get your feedback on that before we get started on the topic. So whether it's master-slave or master-master, intermediate master, within a single data center or multiple ones, and it could be a combination of those, of course, that you might have that you have to deal with. So it'd be great to get your feedback here, and it will give us a good idea also, maybe on the sort of challenges that you have to deal with yourselves in the audience in terms of today's topic. And while you participate in this poll, and just a reminder that you can ask us questions on the content at any moment during the webinar by using the question section of your control panel. So feel free to ask any questions you might have there, and we'll take some time if we can towards the end to answer them, or we'll answer them after the webinar directly to you via email. But either way, we'll get back to you on your questions. So thank you for participating in this poll. I'm just going to close this now and share the results. Wow, okay, so it seems that the vast majority of you are using a master-slave topology. And then it's kind of a split between all of the others. Any comments on this, Krzysztof?
I think that's a very good example that that shows us how MySQL replication is flexible, because master-slave is the most popular one, of course, but again, there are many other types of deployments, and we can find like every of those options had some representation in our attendees. So yeah, that's why we love MySQL replication, for its flexibility.
Great. Well, thank you all for participating here, and I'll just hide this now and hand back to you, Krzysztof.
Okay. So let's get back to our slides and how to deal with topology changes. So basically, if you are using a global transaction ID, it is easy. The GTID makes possible, allows for very flexible topology change. So what you want to do, what you need to do is run change master2, master host, master user, master password, master port, master auto position equal to 1. And then you can slave off any point in the replication chain, and you can move slaves around as you deem fit. And what you want to keep an eye on are the error transactions. So we will be discussing them towards the end of this webinar. So if you do not use GTID, well, the things are much more complex. The problem here is that the slave knows only binary log position of itself and its master. So there is no easy way of knowing that you executed this transaction and you want to slave off some other place in some other location in the topology. This is a problem. There are workarounds here, so you can use binary logs and to find the position, and then parse the relay logs and binary logs of other hosts to identify this. It is error-prone process, it is complex process, and most of the people won't like to do this. So to avoid going through this process, you have to basically stop the replication on an involved subset of hosts before you can actually perform some changes. So I'd like to talk a little bit about how the topology change can look like. I won't be going into details, because this is actually we covered this on one of our previous webinars. So if you're interested, so feel free to check the recordings. But still, I'd like to show you how that it is more complex than running one single change master2 command. So what we want to do here, we want to promote DB2 as a master, basically. So we want to change our topology. So basically, the first step requires to reslave DB3 and 4 of DB2, and for that we have to stop the replication topology. Stop the replication on those 3 hosts at the same position. So we basically induce lock. because that's the only way we can do it without global transaction ID. Well, only way we can do it easily without global transaction ID, and it's not that easy still. So what we need to do is, of course, enable log slave updates on DB2, and then we need to stop them at the same position. So we run start slave until, and we need to pick some position in the future, and then we run flash logs to rotate the logs, and the slave should end up the same position. We need to confirm that, and then we need to check the position, the binary log position of the DB2, and then use this position to slave DB3 and 4 of it. And in this process, there are at least two steps where we could make some errors. And the problem here is that if you make an error with MySQL replication, it may happen that you are not able to recover from it. So if you point to some incorrect location, if you run start slave, then basically you have to rebuild the slave from scratch. So it is error-prone process, and the rest of the topology change is still complex, although GTID can't help here much. But we have to set up the replication between DB1 and DB2, master replication. So we need to confirm there are no writes hitting DB2, and then set up this replication, and then again monitor that everything is fine, there are no writes hitting, and then finally we can fail over. So as you can see, using GTID, we could just run one couple of change master 2, and that's all. And this basically saves like 50% of our problems here. It works for us. So this is one of the examples why GTID are so were so welcomed by MySQL administrators.